Hi everybody. So we are back. This is the second video for equations and inequalities word problems. All right, and I'll do the rest of the problem set in this video. All right, so let's get right to it. This question asks, Olivia has a 20-meter long fence that she plans to use to enclose a rectangular garden of width W. The fencing will be placed around all four sides of the garden, so the area is 18.75 square meters. Write an equation in terms of W that models the situation. Okay, so what I always like to do is I always like to draw a picture, right? So here is the garden. It's going to be a rectangular garden, right, like that. And it says here that Olivia has a 20-meter long fence that she plans to use to enclose the entire garden with a width of W. So let's put width W here. Okay, and then she's going to use 20-meter long fencing. So 20-meter long fencing means that the fence that completely encloses this rectangular area is 20 meters long. So what does that represent? That represents the perimeter, right? The perimeter of the garden is 20 meters long. Okay? Now, it also says the area is 18.75 square meters. So the area of this garden is going to be 18.75. Just lost it. So let me see how long it takes to get back. Okay, we are back. So I just got the picture back. 18.75, right? 18.75 meters square. All right. Now we know that the perimeter is I'm going to call these lengths. Let's call those lengths. Okay, so I know that you can find the perimeter by doing twice the length plus twice the width, correct? And I also know the area is just length times width. There we go. Now in this problem, they want us to find the equation that represents the situation, right? That models the situation in terms of W, in terms of only W, not L. So we have to get rid of the L somehow, correct? And the way we can do that is we could take this area formula right here and solve for L. So let's solve this for L. So I'm going to do it up here, excuse me. 18.75 is equal to L times W. So if I divide both sides by L, and I know L can't be 0 because that's the length, right? You can't have 0 length. If you had 0 length, then you wouldn't have any area, right? So the lengths cancel out here. So W is equal to 18.75 over L. Okay? And now I'm going to take this expression for W, and I'm going to, wait, hold on. I'm sorry, they wanted in terms of W. So let me go back and redo this, find L. All right? Yeah, they said just leave the W. So let me go back. I'm going to do this. I'm going to redo this exactly, but getting rid of the W. So let me do this. Sorry about that. There we go. I'm going to solve this for L. Almost there. Okay, I'm going to use the blue. I'm going to solve this for L. So divide by W. So it's going to be 18.75 over W is equal to L. Okay? Again, the reason why is because in my equation I need W, not L. And then I'm going to take this expression for L and plug it in here. Okay, I use the area formula. Now I'm going to plug that in. So I'm going to get 2 times 18.75 divided by W plus 2W is equal to 20. All right, that is my expression that represents this, right, situation for using W. Okay. All right, guys, so let's type this in. We have 2 times 18.75 divided by W, and then we're going to do plus 2W plus 2W is equal to 20. And that is correct. Okay, let's do one more. Okay. In this problem, we have a finance problem, correct? It's a pretty big problem too. It's a pretty long problem. So let's try to make some sense of it. Okay, we have Anna and Hannah have $80 each. Their friend offered to invest their money, promising to return a sum R times as great as what they invested. So let me just kind of point out. So we have $80 each. They all both start with $80. And their friend offered a return of R times as great as what they invested. Okay? So return a sum R times as great as they invested. Anna was suspicious, so she invested. This is Anna now. Anna, so she invested only $20. However, Hannah invested her entire 80. Luckily, the friend did indeed return a sum R times as great, right? So they got R times their money back. They decided to make another investment. This time Hannah invested all of the money returned to her. Hannah invested all of the money returned to her, and Anna invested the money returned to her and the remaining 60. Again, they got a sum R times as great as what they invested. In the end, Hannah had twice the amount that Anna had. Write an equation in terms of R that models the situation. Now, this problem seems very confusing, right? It's not. If you just read through it a couple of times, it'll make sense. Okay? So, in the end, we're going to have to write something that represents this final situation, correct? In the end, Hannah had twice the amount Anna had. So in the end, Hannah had twice what Anna had. So in the end, let me get the name straight here, right? Hannah had twice, thank you. So Hannah, I'm going to call Hannah H. I'm going to call Hannah H. And I'm going to call Anna A. In the end, Hannah had twice what Anna had. Does that make sense, guys? This is my final expression. Okay, Hannah is ending up with twice as much that Anna had. Okay, Anna had twice as much. Okay, good. Now let's break it down. Let's find an expression for Hannah and also Anna. Okay, they both had 80 each, correct? In the first iteration, it says that Anna was suspicious, only put in 20, and Hannah put in 80. But they both got the return a sum R times as great. So in the first part, oof, what just happened? We just lost. There we go. So this is the first. This is the first time, right? First time. In the first time, we had, excuse me, first investment, first time invested. It said Anna only gave 20, right? So Anna only gave 20. Anna only gave 20, right? She only invested $20, but then she got back R times that. So Anna ended up Anna ends up with 20R. Hannah, however, she invested all $80. So she ended up with 80 times R, correct? Because clearly it says R is R times as great as to each. So Anna had 20, Hannah had 80, so therefore Anna had 20R and Hannah had 80R. That's the first time investment. Now let's go to the second time. Second investment. This time, Anna gave all of her 20. So here's Anna again. Anna gave all of her, let me see here. Let me go back. Sure. Hannah invested all of her money, returned to her, and Anna invested money, returned to her, and the remaining 60. So this time, Anna invests the 20R plus the remaining 60 that she had. And again, this is how much she put in, and she made R times that. So she made this. This, her original, right, what she came out with in the first investment, plus the $60 she had left, and she's going to make R times that in the second investment. Hannah invested all of her money again. So Hannah invested this much, and she made R times as much. Okay? So in the end, this is how much money both Anna and Hannah have. So if I were to plug these expressions in now for H and A, I would have 80 R times R is R squared, of course, right? Is equal to twice this. So this would be 20R squared plus 60R, like that. Okay, so you could put this in, or if you want to, again, you could distribute this, right? You could distribute this and then put it in whichever way you want to do it. All right. Actually, yep, that's correct. Okay, so let's write it in now. We have 80R squared. 80R squared is equal to 2 times 20R squared plus 60R. Okay, let's just make sure that we copied it correctly. So 80R squared is equal to 2 times 20R squared plus 60R. I think we got it. All right, and let's just quickly check, and that is correct. Okay, guys? So again, in these problems, the key is to identify the relevant information, correct? We have to identify what the relevant information is, and I just like underlining it. If you want to copy it over, that's fine too. Then you have to see what they're asking you to do. What is the final product? Okay? How are you going to set up the final relationship? And then find the mathematical formulas or the expressions, okay, that represent the situation. Okay, so again, get the important information, find what relationship that they want you to end up with, and then interpret or translate the information that you have into the mathematical models using, of course, mathematical symbols and numbers. All right? Okay, take care, guys. All right?